Make Solar Energy Economical, presented by Bryson Hamlet, Liberty University. Energy fun facts. The sun produces 1.7 times 10 to the 22nd joules of energy in 1.5 days. The sun's energy is equal to 3 trillion barrels of oil. Humans use 4.6 times 10 to the 20th joules in 1 year. The generation of electricity using photovoltaic PV cells. System generating an electric current. They are the generation of electric voltage between two electrodes attached to a solid or liquid system. The picture presented beside is a visual representation. Ideal photovoltaic cell materials. Band gap between 1.1 and 1.7 eV. The material should have a direct band structure. The material should be readily available and non-toxic. The material should be suitable for large reproduction. The material should have good PV conversion efficiency, and the material should have a long-term stability factor. The generational PV cells. There are the first generation, second generation, and third generation. Within the first generation, it is made up of a crystalline silicon. The monocrystalline silicon is 25% efficiency. The polycrystalline silicon is 20.4% efficiency. They are more efficient at lower temps and require less area for given power. Second generation is a thin film cell. It's lower cost, it has lower efficiency, and the different types are amorphous silicon, cadmium telluride, copper indium gallium selenide, and they are low efficiency. The third generation is an improvement of the second generation, and its main attraction is the low cost. It aims to reduce power costs by 50% to 80%. The efficiency chart for solar cells. It is created by the National Renewable Energy Laboratory, which is also within the article. The multi-junction solar cells have the highest efficiency, and it is comparable with fossil fuels. PV cells electricity production trends. Increased interest in the PV cell electricity. The estimations are for high radiation areas, and the PV cost advantage over fossil fuels is expected in 2028 and 2046. Both of these charts are also applied from the article used. The generation of electricity, concentrated solar power. Solar radiations are concentrated to produce steam or heat. The steam or heat is then used to produce electricity. The CSP technologies, also known concentrated solar power. There are parabolic troughs, power towers, dish engine systems, and linear Fresnel reflectors. The CSP technologies, the first two are parabolic troughs and power towers. The parabolic troughs track the sun through the day for maximum radiation. The radiation is focused on one receiver. It's minimized radiation loss. It is most proven and economical. There are 9 large-scale plants in California, and it consists of trough collectors, steam generation or heat transfer systems, Rankine steam turbine or generator cycle, and a thermal storage system. The power tower, on the other hand, is a heliostat distributed mirrors that track the sunlight all day. The sunlight is concentrated onto a central tower. The receiver absorbs the energy, and the temperatures go from 800 degrees Celsius to well above 1,000 degrees Celsius. The other two are dish engine and linear Fresnel reflectors. The dish engine is a parabolic dish-shaped concentrator. It reflects direct solar radiation to a focal point receiver. The receiver can either be a Stirling engine or a turbine. There is no heat loss due to location of the receiver, and it is thought to have the highest efficiency of roughly 30%. The linear Fresnel reflectors is a series of long, flat, or curved mirrors, and they are placed at different angles to concentrate the light. It has a long tube receiver, and it is cheaper than the parabolic trough. The direct use of solar energy. There are a few: agriculture, solar vehicles, cooking, water treatment, fuel production, and outer space. For agriculture, it is based off the solar desalination process that converts brine to fresh water. Solar vehicles is to achieve sustainable mobility with less use of fossil fuels. Cooking, because in many countries with wood, switching to solar would save the environment. Water treatment with photocatalysis for gradation of organic pollutants in water and air. Fuel production to convert solar energy into hydrogen or chemical fuel for storage. In the outer space is so satellite power stations orbiting Earth can convert solar energy into electricity, then convert to a microwave beam and send it to Earth. Looking into the future, solar energy is our most sustainable resource. It continues to improve and produce electricity at competitive rates, and it is expected to pass the conventional ways of electric generation by the end of 2032. The graph on the top right has also been inputted from the article. Technical challenges. Increased efficiency is needed to be more competitive with leading energy producers. Unknown area of abundant materials required. Requirements, codes, and regulations must be met for implementation. Drastic drop in price since 2000 for economic analysis. The cost of a PV system has dropped $10,000 per kilowatt from 1992 to 2008. The levelized cost of solar electricity is still too expensive. The environmental challenges. We have 80% less greenhouse gases emitted for solar water heating, 40% less greenhouse gases emitted for solar space heating. The carbon dioxide emission savings, it can prevent water pollution and air pollution, but a lot of land is taken for the large equipment, and it will take away part of habitats from animals. Storage challenges. There are thermal and solar electric storage. Thermal is the building costs are expensive, 90% of storage efficiency. The types are sensible heat storage, latent heat storage, and thermochemical storage. Solar electric energy, there is no ideal options. The types are flywheel, capacitors, supercapacitors, fuel cells, and more. Future research and recommendations. There are plenty of questions and future research that can be done on this topic. More have been listed within the article if needed. Thank you.